job, but like I said, unfortunately, I just was unable physically to even sit up yesterday. Bizarre. Okay, so the record is going. From algebra, ladies and gentlemen, hopefully you recall that if you were given the graph of a line and the plane, we were able to write the equation of that line, whether we use the slope form, slope-intercept form, y equals mx plus b, or the point slope form to write the equation of the line. And of course, we needed to know some information from the line in order to, write the equation of the line. We had to know the slope of the line. We also needed to know at least one point on our line. Preferably, it'd be great if we knew the y-intercept, because that would mean we could just simply put things into the slope-intercept form to derive the equation of that line. But ladies and gentlemen, this being trigonometry, we're not writing equations of lines today. We're going to learn how to write the equation of a trigonometric graph. Okay, and so I think the best way to do that is just to begin to dive right into the problems in section 4.4 and attempt to start doing such a thing. Now, in general, like I said, we're going to need to know the amplitude, the period, any horizontal phase shift or vertical phase shift. Specifically, the amplitude is the absolute value of some number called A. The period is always 2 pi divided by some number called B. The horizontal phase shift is always negative c divided by some number b. And vertical translation is going to be, your author calls it some number k. So in general, ladies and gentlemen, our sine or cosine functions are going to be of this form: k plus or minus. You could have the minus there too. A sine bx plus c, or for a cosine function in general, we're going to have k plus or minus a cosine of bx plus c. So in general, if we know the amplitude and we know the period, we should be able to determine what B is. And if we know any horizontal phase shift exists, we should be able to determine what C is. And if we know if there exists any vertical translation, we would know what this number K would be out here. If there's any reflection about the x-axis, we would go from having a positive to having a negative in front of our trig function. So in general, this is the skeletal form of the cosine or sine function that we're aiming for when trying to write the equation from a trigonometric graph. So this is what we need to remember, these skeletal forms, okay? And we need to know, of course, what the A is and the B and the C and the K is, and what they will enable us to find for the, or would enable us to determine from the graph, okay? So this is what we need to remember. Let's go back to our textbook. And these are on page, let's see, page 221. Now, problems 5 and 6 are very, very simple problems to begin with. Okay, hopefully you realize they are. Ladies and gentlemen, number 5 is the graph of what basic trig function? Can we determine that just visually by looking at this? We've seen this over and over again.
That's a sine.
That's just a sine. This is just a graph of y equals sine x. It's that simple. We've seen this one over and over again. Okay. Notice the period of this graph is 2 pi, because if you take 2 pi and subtract off 0 where the graph begins, you have a period of 2 pi. That's one cycle for this graph. The amplitude is 1, because if you take the absolute value of 1, the maximum y value, subtract off the minimum y value of -1, so you have the absolute value of 1 subtract -1, which is really the absolute value of 2, divided by 2 is 1. The amplitude is 1. So the period's 2 pi, the amplitude is 1. Notice there is no horizontal phase shift for this sine function. There is no vertical phase shift. For that reason, the equation that models this graph would be y equals sine x. That's simple. What about number 6? You recognize it?
Cosine of X.
This is just the graph of the basic cosine function, y equals cosine x. The period of which is 2 pi, the amplitude of which is 1. And so this is the graph of y equals cosine x. So I cannot emphasize this enough. Ladies and gentlemen, in order to be successful in writing equations of sines and cosine functions from their graphs, we have to have these emblazoned in our mind, okay? We need to know or remember or memorize the graph of the basic sine function right here. We need to remember or memorize the graph of the basic cosine function right here. And of course, if this graph here in number 5 was reflected about the x-axis, we need to have that one memorized, where the graph would start at 0 and then would go down to its minimum value at pi halves down to -1, come back through the x-axis at pi, max out at 1 at 3 pi halves, and then come back down to the x-axis at 2 pi. That would be the graph of y equals negative sine x. The graph of y equals negative cosine x would have the graph of number 6 flipped about the x-axis, where at x equals 0, the graph would start at -1, come through the x-axis at pi halves, max out at pi at a value of 1, come back down to the x-axis at 3 pi halves, and then min out again at 2 pi down here at -1. That would be the graph of y equals negative cosine x. So if we have memorized the graph of the basic sine, the basic cosine, the graph of the negative sine of x, and the graph of negative cosine x, if we have those memorized, it's going to greatly aid our ability to write the equations of other sine and cosine functions that deviate from the basic ones. All right, so remember number 5 and number 6, and of course the flipped versions of these. Let's move on now. Having these memorized, notice the sine function starts low and goes to its maximum value. The cosine function starts high and goes to its minimum value. Notice the difference between the sine and the cosine function. All right, let's move on. Okay, ladies and gentlemen, problem number 7 here. We have the graph of either a sine or a cosine function. We need to write the equation of this particular graph. All right. Now, what is the amplitude of this wave here? What's the amplitude? Anybody?
Amplitude of 3.
3 is the amplitude, okay? So, tell you what, let's document that on our paper that the amplitude is 3. Just jot that down. Of course, that will be the absolute value of A. And that literally will be A in this case, that number A. What's the period of this graph?
Period is 2 pi.
2 pi. Notice, one cycle, we go from a crest to a crest. And the distance you have to travel to go from a crest of a wave to another crest of a wave is 2 pi. That's why we say the period of this wave is 2 pi. Let's write that down. Period equals 2 pi. All right. And therefore, ladies and gentlemen, since the period is 2 pi, we know that's equal to 2 pi divided by B. Look what I have on my paper so far. We know the amplitude is 3. That will be our A. We know the period from the graph is 2 pi. That better be equal to 2 pi divided by that number B. Therefore, this implies then that B would be equal to what? What does B have to be equal to? If we say 2 pi is equal to 2 pi over B.
B is equal to 1.
This implies if you solve this equation for B, B would be equal to 1. So we know that now. We know A, we know B. All right, let's go back to the graph. Now, does it appear that is there a horizontal phase shift with this graph? It does not appear there's a horizontal phase shift because notice Well, first of all, Reza, what function would you be leaning towards? Is this a graph of a sine function or cosine function? What do you think? Number 7 seems to mimic which one, 5 or 6?
6, which would be a
6.
cosine.
Yeah, you can clearly see, look at number 7 seems to mimic number 6. And number 6 is a cosine function. So we're going to try to model our graph according to a cosine function, not a sine function. What is the only difference between the graph in number 7 and number 6? The periods are the same, both 2 pi. What's the difference between
The
the
amplitude.
amplitude? Notice amplitude for number 6, the basic cosine function is 1. Notice in number 7, the amplitude now is 3. That's the only difference between the graph of 7 and 6. For that reason, there is no horizontal phase shift that has occurred between 6 and 7. And there's no vertical phase shift. The graph has not been translated upwards or downwards. The only difference is the amplitude has gone from being 1 to 3. For that reason, we should be able to write the equation of number 7's graph there. So there is no phase shift. Or, ladies and gentlemen, we would say the phase shift is equal to 0, which is equal to negative c over b, which is equal to negative c over 1, because b we found is 1. So therefore, this implies that negative c is equal to 0, which implies that c is equal to 0. There is no vertical translation with the graph. And therefore, k is equal to 0. So we can write the equation of this. So in general, and notice the graph has not been flipped about the x-axis. So in general, to write the equation of this cosine function, we know k is 0. We know a is 3. We know b is 1. We know c is 0. Ladies and gentlemen, there you go. That's your answer for problem number 7. Y must be equal to 3 times the cosine of x. Do you see the approach we took in doing this? First, we determined key information from the graph. By using that key information, we were able to determine what k is, what a is, what b is, and what c is. Once we know all those values, we can simply write the equation for the graph. That's the approach we're going to take for all of these. Any questions about number 7? All right, number 8. First of all, ladies and gentlemen, just by looking at the graph of number 8, would you be leaning towards thinking that's the graph of a sine or cosine function? Number 8 seems to mimic what graph? Number 5 or 6?
5, which is a sine.
Sine, which is a sine function. So it looks like we're going to try to model the graph of number 8 according to a sine function. Okay. Okay, now what's the amplitude of this graph? Amplitude. It appears
2.
2. All right, so we'll write that down. So for problem number 8, the amplitude is 2, which means that would be our A. Does not look like this graph has been flipped about the x-axis. So A would be positive 2. The period is what? Period is clearly 2
pi.
pi. 2 pi then the period would be equal to 2 pi divided by b, which would imply then that number b would have to be 1 in our equation. Does it look like this graph has experienced a horizontal phase shift? Does it look like the graph of number 5 has been shifted right or left to give us the graph of number 8?
It has stayed put.
Yeah, it doesn't appear to have any horizontal phase shift. That would indicate that there is no phase shift, which would imply that that number C would be equal to 0. And notice it does not appear that this graph in problem number 5 has been shifted upwards or downwards. Granted, the amplitude is different, don't get me wrong, but I'm saying the graph, the whole graph has not been shifted upwards or downwards to yield graph in number 8. So there appears to be no vertical phase shift. So no vertical translation, if you will. And that would imply then that our number K is equal to 0. And so to write the equation of this graph is pretty simple, knowing all this information. Y would be equal to K is 0, A is 2. We know we're modeling it according to a sine function. B is 1, C is 0. Ladies and gentlemen, that's the graph of number 8, y equals 2 sine x. So these are pretty simple so far, correct? Pretty straightforward and simple so far. All right. Again, we always feed off of what we know from the basic trig functions. This is the graph of the basic sine, the graph of the basic cosine, and of course, we would envision in our minds what the graphs of the flipped versions would be. The graph of negative sine x would look like this. The graph of negative cosine x would be a graph that starts at -1 and goes like this right here. Okay. Knowing those, we should be able to write the equation of any one of these problems in section 4.4. All right, number 9, ladies and gentlemen, we have a graph of either a sine or cosine function. We have the graph of one period or one cycle. Which one would you lean towards it being, ladies and gentlemen, the graph of a sine or a cosine function? Which one does this one appear to mimic the best or closest? Number
Cosine.
5 or 6?
6.
Okay, 6, cosine. Why? How is our graph in number 9 different than the graph in number 6? What has happened to the graph of number 6 to give us the graph of number 9? What's happened? Flipped. First of all, it looks like our graph has flipped about the x-axis because we're not starting at x equals 0 high, we're starting at x equals 0 low. You see, we're starting at -3 low at x equals 0. So it looks like the cosine graph has been flipped. Okay, what is the amplitude of this graph?
3.
Okay, so the amplitude is 3. So for problem number 9, let's write that down. The amplitude is 3. But ladies and gentlemen, we notice that the graph appears to have been flipped. So this would imply then that A is equal to positive or -3. If the graph has been flipped, would A be positive or -3? Because the graph has been flipped or appears to have been flipped, we would say that A would be a -3. Remember, by multiplying a trig function by a negative, that causes the graph to be reflected about the x-axis. All right, the period. What would be the period of this graph in number 9? It appears that the period is 2 pi. We go from trough to trough, and the distance to go from trough to trough, think of like a water wave on a lake or something. To go from trough to trough, we have to travel a distance of 2 pi. That's the period of one cycle of this graph. But we know the period in general for any sine or cosine function is 2 pi divided by b. So since the period is 2 pi, we know that this implies that b is equal to 1. So this is what we know so far. We know that A is -3 and B is 1. All right, let's go onwards now. Okay, now another thing. Does it appear, ladies and gentlemen, that the graph of the basic cosine function, which is up here, has been shifted to the right or left to give us the graph of number 9? In other words, has this graph of number 9 experienced a phase shift? What do you think?
No.
Does not look like it. Hasn't been shifted to the right or left. Has the graph of the basic cosine function of number 6 been shifted upwards, translated upwards or downwards to give us the graph of number 9? Granted, the amplitude's different. I'm not talking about the amplitude change. I'm talking about the whole graph being shifted upwards or downwards. It does not appear that that has occurred either. Therefore, that being the case, all that information being the case, we would conclude then that there is no phase shift. And this would imply then that that number C is equal to 0. and there is no vertical translation. And this would imply then that k is equal to 0. I think we're ready to write the equation of that graph, ladies and gentlemen. We know it's a cosine, so y is equal to k is 0, a is -3 times the cosine, b is 1, and c is 0. That should be it. That would be the equation that represents the graph in problem number 9. Y is equal to -3 cosine x. Any questions about number 9? How we've taken the graph and we've written its equation. What would be the equation for number 10 then? First of all, ladies and gentlemen, would you lean toward just being the graph of a sine or cosine function?
Sine function.
Sine function, okay? Notice with the graph of a basic sine function, you can see clearly one whole crest of the wave and one whole trough. With the graph of one cycle of the cosine function, you can only kind of see like one whole trough, but only half of a crest, either here or here. So it looks like number 10 would be a sine function. How does the graph of number 10 differ from the graph of number 5? What are the differences? What's the differences between the graph of number 5 and 10? Anybody?
Amplitude.
Amplitude has changed from being 1 to being 2. What else appears to have changed, ladies and gentlemen? The amplitude has gone from 1 to 2. What else appears to be different between this graph and 5 and 10 here?
It got flipped.
It's been flipped. Notice the graph of the basic sine function has a starting at x equals 0 at 0, and then we go up towards the highest point. The graph of number 10 at x equals 0 has a starting at 0 again, but we go towards not the highest point, but the lowest point. It appears that the graph of the basic sine function in number 5 has been flipped about the x-axis. So two things are different between the graph of number 5 and 10. The amplitude has changed from 1 to 2, and we've experienced a flip or reflection about the x-axis. Therefore, ladies and gentlemen, what would be the equation for number 10? Can anybody give me the equation for number 10?
No.
Go ahead.
Y is equal to -2 sine x.
That's it. That is it. Okay. Y equals -2 sine x. I mean, that is it, because there's no vertical translation of the graph. K is 0. A would be -2 because of the fact that the graph's been flipped about the x-axis. Amplitude is 2. B is 1 because the period of this graph is 2 pi. There's no horizontal phase shift, so C is 0. That would be the equation then. All right. Okay. Ladies and gentlemen, what I'm going to do is I'm going to give you some time to do problem number 11 now. This is not part of your classwork. Okay, this is not your classwork. This is something I want you to do right now. I want you to look at number 11. I want you to think about it, and I want you to approach it the way I've been approaching all the other ones. I want you to write the equation for number 11. Go ahead and do that. I'll give you a couple minutes to work on this. Number 11. Okay, what do you think? What did we get, ladies and gentlemen, for the equation? Anybody got the equation of number 11?
Y equals sine 3x.
Y equals 3x. If you look at the graph, notice we know the amplitude is 1. Notice I'm leaning towards a sine function, not a cosine function. There appears to be no reflection about the x-axis, so A is equal to +1. The period is 2 pi thirds. But we know to find the period of any sine or cosine function is always 2 pi over this number b. So 2 pi over b must be equal to 2 pi thirds. Solving for b, we get b must be 3. There appears to be no horizontal phase shift. So negative c over b equals 0 implies that negative c over 3, b being 3, is 0, which implies that c is 0 after you solve this equation. There appears to be no vertical translation, which indicates that k is 0. Hence, ladies and gentlemen, our equation would have to be y is equal to sine 3x. B was 3, remember. That'll do it for that one. Hopefully we've all gotten that there. Anybody have a question on that if they did not get it or had any complication? Okay. All right, that was number 11. Now, ladies and gentlemen, I want you to write the equation for number 12. Write the equation of this graph for number 12. Go ahead and do that. All right, Haley, have you come up with any sort of an equation for number 12? What do you think it might be?
Well, I got all of them except for the period because I don't know what to do when it's just pi.
Okay, so let's look at this graph and try to figure out what the period is. If we go from the high point at 0, 1 on this graph to the other high point that occurs at pi 1, this point here, what distance do I have to travel on the x-axis to go from crest to crest of this wave? What distance do I have to travel, horizontal distance?
Pi.
Pi. So that appears to be the period for one cycle of this graph, pi. Okay, so the period is pi. Now, so we know the amplitude is 1. The period is pi. Haley, what trig function would you be leaning towards to write the equation of this thing? Sine or cosine? What do you think?
Cosine.
All right, cosine. So we're leaning towards cosine. We know the amplitude is 1, the period is pi. It does not appear that there's any horizontal shifting of this graph because this graph has not been shifted relative to the graph way back up here of number 6, the basic cosine function. It hasn't been shifted right or left. Granted, the period is different, ladies and gentlemen, but the graph has not been shifted in the sense that the graph still starts out at its high point at x equals 0. Okay. So this value, this point here, 0, 1, has not been shifted right or left. The graph has also not experienced any reflection about the x-axis because notice at x equals 0, the graph starts high and goes down towards its low value. Same thing with number 12. It starts out high at x equals 0, 0 and goes down towards its low value. All right, so knowing all this information here, knowing all that information, we can start to derive what A, B, C, and K must be. A, the amplitude would be 1, positive 1. The period is pi, so therefore 2 pi over B has to be equal to pi. Solving this equation for B, multiplying both sides by B, dividing both sides by pi, we get B must be equal to 2. There is no horizontal phase shift, so negative C over B must be 0, or in particular, negative C over 2 must be 0, which means if you solve this equation for C, C must be 0. There's no vertical translation, so K must be 0. Hence, ladies and gentlemen, fitting things into our skeletal form of our cosine function, Y must be equal to cosine 2x. Of course, our A out here is positive 1 or amplitude. Okay, so that would be the equation for that graph there. All right. Austin, did you get that that function correct? Justin, did you get that one correct? Anthony, did you get that one correct?
Yep.
Okay. Let's take a look. Let's go on down. Tell you what. Let's go on down further. Number 13, ladies and gentlemen, quickly. Would it be a sine or cosine function? What do you think? Sine or cosine, number 13?
Oh, it's a sine function all day.
Sine. It's sine. Number 14, sine or cosine?
Cosine.
Cosine. Number 15, cosine or sine?
Cosine.
Cosine.
Cosine. Number 16, sine or cosine?
Sine.
Sine. 17. Looks like a sine.
It's a sine.
What would be the period for number 17? The period.
2.
2. 18 is a cosine. Okay. All right. Number 19, sine function. Number 20, cosine function. Now, ladies and gentlemen, number 21. Okay, what would you be leaning towards for number 21? Sine or cosine?
Sine.
Sine function. So number 21, we're going to try to model according to a sine function. All right. Now, ladies and gentlemen, what is the amplitude of this graph of number 21?
4.
All right. You got 4. How did we get 4? Well, remember, we had a formula. I'm just gonna, jog our memory again with this formula. There's gonna be times for more difficult cases we're gonna need this formula. This is how we find the amplitude. Remember, you take the absolute value of the Y maximum value on the graph, subtracting off the Y minimum value on the graph, and then dividing that by 2. Notice, let's go back to our graph now. Notice for this graph, the maximum Y value found in this graph is 6. The minimum Y value found in this graph is -2. So feeding things into this formula here, the maximum Y value is 6, subtract the minimum Y value of -2, divide that by 2. 6 subtract the -2 is 6 plus 2, which is 8. The absolute value of 8 divided by 2 is 4. You are correct. The amplitude is 4. Ladies and gentlemen, got a question for you. We're trying to model this according to a sine function. Does it look like this graph of our sine function has been flipped about the x-axis? Now look at, I want you to compare this graph, number 21, with the one way back up here. The basic sine functions graph number 5. Notice at the first input value on the x-axis, the graph of the basic sine function starts low and goes towards its maximum point from left to right. Does this one start low and go towards its maximum point? Or does it start low and go towards its minimum point, ladies and gentlemen? It starts here at x equals 0 at 2, but then goes towards not its maximum point, but towards its what? Minimum point. Meaning the basic sine function has been what? Flipped about the x-axis. So there is a reflection about the x-axis. Notice. So for 21, we need to realize that the sine function has been reflected about the x-axis. Because of that, knowing that the amplitude is 4, ladies and gentlemen, our A would be what? Not +4, but A's got to be a -4 because there was a reflection about the x-axis. All right, so that's what A has got to be. All right, now let's go back and look at the graph and try to determine what the period of the graph is. What is the period of this thing?
Period is 2.
2. Notice we start here at 0, 2 on our way down towards the minimum value. The distance you have to travel from this point to a point that mimics or reflects this point, 0, 2, would be from here to here. At this point here, 2, 2, ladies and gentlemen, the graph is also on its way down to another minimum value down here, another trough down here. So this distance from here to here, or from trough to another trough, which would be over here, or from crest to crest, there'd be another crest over here if you were to continue this function's graph. The distance is 2. The period is 2. All right, so we know the period is 2. But to find the period of any sine or cosine function, we know we always take 2 pi and divide it by b. So that better be equal to 2. Now to solve this equation for b, we have 2b is equal to 2 pi, divide both sides by 2. This implies that b is equal to pi. B has got to be equal to pi if the period's to be 2. Okay, horizontal phase shift. Does it look like the graph of our basic sine function, which is way back up here, has been shifted right or left? Notice our starting point on the basic sine function starts on the y-axis. Is that the case also, ladies and gentlemen, with number 21? Notice the graph starts also on the y-axis as we move from left to right. So it does not appear that a horizontal phase shift has occurred. The graph has not been shifted to the right or left. Okay, so since the graph has not been shifted right or left, there is no phase shift. Ladies and gentlemen, no phase shift implies that negative c over b must be equal to 0, which implies that negative c over pi, remember b is pi, must be 0, which implies that c must be 0. Vertical translation. Has our graph been translated vertically? Notice with the graph of the basic sine function way back up here with number 5, the graph starts, ladies and gentlemen, on the x-axis at 0, 0. Starts on the x-axis. But notice number 21, our graph does not start on the x-axis. it starts up here at y equals 2. So it looks like the graph of the basic sine function has been translated what? Up or down 2 units? What do you think, ladies and gentlemen? Up or down 2 units? Has it been shifted up or down 2 units?
It's been shifted up.
It looks like is shifted upwards or translated upwards 2 units. All right, it looks like we have a vertical translation of 2 units. So vertical translation is 2, which implies that number k has got to be equal to 2. We can now write the equation of that graph. Y is equal to k, which is 2, plus a, but a is -4, times the sine of b times x, but b is pi, plus c, but c was 0. Ladies and gentlemen, that will be the equation that models number 21. That's the equation for number 21's graph. You see the analysis and the routine we pour into this to derive the equation. Okay, you see how we go about getting the information from the graph that we need to build the equation. Okay. That making sense how we did that one? Any questions on number 21? All right. That being the case, ladies and gentlemen, tell you what. I want you to do number 22. I'll give you a couple minutes. I want you to write the equation for problem 22. Go ahead and do that. The equation for number 22. All right. For this problem here, we would be thinking not sine, but some sort of a cosine function. Ladies and gentlemen, what, in your estimation, as you were trying to do this problem, what was the most difficult aspect to deal with? Was it the amplitude, period, phase shift, or vertical translation? What was the most difficult aspect for this graph? Anybody?
Vertical translation.
Vertical.
Yep.
The vertical translation is a real problem, isn't it? It looks like our graph has been vertically translated. It looks like the graph of the cosine function has also been reflected about the x-axis. There is no phase shift, no horizontal translation or shifting. It's that vertical translation that's really the confounding thing in this problem by far. Okay. But nonetheless, take it from the top. The amplitude of this graph would be what? What's the amplitude? Anybody?
-2.
Okay. Well, the amplitude is 2, but you're saying your A would be -2. Is that correct?
Yeah, that's right.
Yeah, because it looks like the graph of the basic cosine function has been flipped about the x-axis. Because, you know, if you go back to the basic cosine function, way back up here, notice the graph starts on the x-axis, but then goes towards its minimum point. But down here with our problem, number 22, we start on the x-axis, but we go towards the maximum point. So yeah, there has been a reflection about the x-axis. So A would be -2. The period would be what? What's the period? Looks like 2, correct? The period would be 2, which would imply that our number B would be what? What would B have to be if the period is 2? What would B have to be?
Pi.
Pi. Would have to be pi. There is no horizontal phase shift, so C would be 0. And now, ladies and gentlemen, the vertical phase shift or the vertical translation is the toughest part. Okay. Now, we know the period, we know the amplitude of this graph is 2, correct? We know the amplitude is 2, and it's been reflected about the x-axis. Here's how, ladies and gentlemen, you can get a foothold on what type of vertical translation this thing has realized. Here's what I recommend you do. Let's graph the basic cosine function with an amplitude of 2. That's what I've done here. I've graphed the basic cosine function with an amplitude of 2. So you're looking at it right here. Everybody see that there? Now, if you were to reflect this graph about the x-axis, you would have the graph of the dashed curve. Still, the amplitude of this cosine function has been reflected about the x-axis is still 2. Now, ladies and gentlemen, we're ready to deal with the vertical translation. How many units vertically would I have to shift this dashed graph upwards so that this point here, -2, goes to +1? This has to go to +1. And this point, which is at 2 here, has to go to +5. How much vertically would I have to shift this graph here?
So that'd be a 3.
3 units up. Do you agree? You'd have to shift the graph 3 units up for this point in -2 to go up to +1, and this high point to go from 2 to +5. So then your graph, when you do that, would then look like this. Okay, and that's what the graph of number 22 looks like. It looks like this. At 0, it starts at 1 for y, goes up to a maximum value of y of 5, and then goes down to here. Okay, so it looks like the vertical translation is 3. That would be our k value. Now, again, how did I ascertain that? Because I know I might have went through that kind of fast. Here's what I did. I said, this is a cosine function. We know the amplitude is 2. Okay, since we know the amplitude is 2 and it's a cosine function, first of all, let's just graph the basic cosine function with an amplitude of 2. In other words, I just want to graph y equals 2 cosine x. That's all I want to do. Well, here's the graph of y equals 2 cosine x. Then what I did is I took the graph of the basic cosine function, 2 cosine x, and I reflected it about the x-axis because I know my graph is reflected to number 22. So reflect it. This then would be the graph of the cosine function y equals 2x reflected about the x-axis. Now I ask myself, how many vertical units do I have to translate this graph in order to have it become the graph of number 22? Notice -2 has to be shifted up 3 units so that this starting point would be at 1 up here. The high point, which is at y equals 2, would have to be also shifted up 3 units, which puts it at 5. And that's exactly what's going on with number 22, whose graph is this graph right here. Okay. So knowing all this information, we can write our equation. So y is equal to, our vertical translation is 3. A is -2. Cosine B, B would be pi. X and C is 0. Ladies and gentlemen, that would be the equation for number 22. That would be its equation. That one was more challenging because we had a vertical translation. And that took some thought as to, you know, how to write the equation of this thing here. Okay. I'm just kind of taking a look here. All right, let's try to do number 23 together, and then I'll give you your classwork. First of all, sine or cosine for 23?
Cosine.
Like a cosine. All right, what's the amplitude?
3.
Yeah, looks like 3. Maximum y value is 3. Subtract the minimum y value of -3. 3 subtract -3 is 6. 6 divided by 2 is 3, an amplitude of 3. Does it look like this cosine graph has experienced a reflection about the x-axis? Notice the furthest point to the left on the graph starts up high and then goes down towards min. Starts high and goes down to the min. Look at the basic cosine function up here. Starts high and goes down to the min. Ladies and gentlemen, it does not look like we have a vertical reflection about the x-axis. So it has not been reflected about the x-axis. All right. So therefore, this implies that A would be 3. All right, period. What would be the period? Careful here. What's the period of this graph?
3 pi over 4.
All right, you're saying the period is 3 pi over 4. Is the distance from the crest to the crest 3 pi over 4?
Never mind.
No.
Yeah, that's not correct here. Notice, ladies and gentlemen, it appears that we have a vertical phase shift that has occurred here, which is confounding our ability to determine the period. All right, look, here's how you can determine the period. Ladies and gentlemen, you take the maximum x value, subtract off the minimum x value. That's how you always determine the period of a sine or cosine function. The maximum x value is 3 pi fourths. Subtract the minimum x value is -pi fourths. So 3 pi fourths minus a -pi fourths is 3 pi fourths plus pi fourths, which is 4 pi fourths. And therefore the period is pi. The period is pi. Meaning 2 pi over b better be equal to pi. Meaning when you solve for b here, b better be equal to what? 2. B has to be 2. All right, phase shift. Ladies and gentlemen, do we have a phase shift here? Notice if you go back to the graph of the basic cosine function, we come way back up here at number 6, the basic cosine function's graph starts on the y-axis and does its thing, either goes to a min or a max, okay? Ours does not start on the y-axis. Ours starts where? Ours does not start at x equals 0, ladies and gentlemen. Ours starts at x equals what? At negative pi fourths. So it looks like our cosine function's graph has been shifted to the left pi fourth radians. Okay, so we have a horizontal phase shift of pi fourth units to the left, meaning, ladies and gentlemen, that our phase shift is negative pi fourths, which implies that negative c over b better be equal to negative pi fourths, which implies negative c over b, but b we discovered is 2, better be equal to negative pi fourths. Now we solve this equation for c, basic algebra. So we have negative 4c is equal to negative 2 pi as I cross multiplied and equated to cross products. Solve for c, dividing both sides by negative 4. We get c is negative 2 pi over negative 4, which means we have pi halves. Ladies and gentlemen, c must be pi halves. C has to be pi halves. Vertical translation. Does it appear that our graph of the basic cosine function has been translated to give us the graph of 23? Does it appear that that's the case here? Notice the amplitude is 3, so the amplitude is different than 1 for the basic cosine function. I don't care about the amplitude. Does it look like the whole graph's been shifted upwards or downwards?
No.
Does not appear to be the case. Now here, let's see why. Let's go back to the basic cosine function. Notice the basic cosine function still has its x-intercepts. Okay, notice on the x-axis. And those x-intercepts are halfway in between the highest y value and the lowest y value. Notice the x-intercepts are halfway in between the highest y value and the lowest y value. Let's go down to number 23. Notice for number 23, ladies and gentlemen, the x-intercepts are halfway in between the high y value on the graph and the minimum y value on the graph. Because the x-intercepts are halfway in between the maximum y and the minimum y, this graph has not undergone a vertical phase shift. Notice up here, ladies and gentlemen, that we do have a vertical phase shift that has occurred here. Okay. For number 22. What has happened is the x-axis has been translated upwards 3 units. So if you envision the x-axis going through y equals 3 here, you'll see that the x-intercepts, the displaced x-intercepts in this graph are halfway in between the maximum y value and the minimum y value. This is clearly a vertical translation that has occurred here. Here, there is no vertical translation for number 23. All right, so equals 0. So that implies that k is 0. Let's write our equation now. So y is equal to, there is no vertical translation. A is 3, and that is a cosine function. B is 2. C, ladies and gentlemen, horizontal phase shift is negative pi fourths, which implies that C has to be plus pi halves. This would be your equation for number 23. Okay, that would be your equation. All right. I have one problem for you to do for classwork. One problem for you to do, Liz Owen. Let's see if you can do number 26. So problem 26, we will do this one for classwork. I want you to write the equation of this trigonometric functions graph, number 26. That'll be classwork for July 28th. I will post the lecture video from yesterday when I get done here, and also the homework for yesterday's section and the homework for today's section. I'll get that updated because I'm feeling a little better now, able to at least set up. So I should at least be able to get that posted all for you. Does anybody want to give us the equation for this graph? Does anybody feel confident enough to share it with us?
I actually have a question.
Go ahead.
Is the maximum and min supposed to be like 2.5?
Yeah, I mean, that's the first thing that I had to look at very closely here. When you first look at it, it looks like the maximum Y value is like 3. But then, ladies and gentlemen, you look at the minimum Y value down here, and it is not -3. It is like -2.5. So I had to take a closer look at the Y max value. I had to take a ruler literally and connect that high point over to the Y axis. And believe it or not, it looks like 2.5 is Y max and -2.5 is Y min. So that's the first thing that, you got to be a little careful with. It should be 2.5 for the max and -2.5 for the min. So, all right, anybody get the equation? Feel lucky enough to share it with us? Anybody? First, is it a sine or cosine function? What do you think?
Sine.
Looks like a sine. Looks like our sine function has experienced a vertical reflection about the x-axis. Looks like it's also experienced a phase shift. It's been shifted to the right by pi/4 radians. Notice, because the graph does not start on the y-axis like the basic sine function does. Okay, and there is no vertical phase shift because the x-intercepts occur halfway in between the minimum y value and the maximum y value. All right. Okay, so with all that analysis poured into this here, we know the amplitude therefore would be 2.5. So A would have to be -2.5 because this thing has been reflected about the x-axis. The period, as it turns out, is pi. You take x max, subtract off x min. You get a period of pi, which therefore implies that B would have to be 2. The phase shift is pi/4, which, ladies and gentlemen, then you use this equation here. So -c/b must be pi/4. B being 2, then you just solve for C. C has to be -pi/2. The vertical translation, there is none, K is 0. Therefore, this would be the equation for that graph of number 26. This would be the equation. And we are done. Okay. So